around 11 years of IT experience, including 6 years in big data Hadoop technologies. I'm currently working as a big data Hadoop specialist in an MNC company, having on-site experience to Tulsa, Oklahoma as well, handling multiple big data projects. So in today's session, I would take this opportunity to give a bird's view on what is big data Hadoop and what are its ecosystems. Okay. So try to be live. It's not like I say something for the next 40 to 45 minutes and you listen. Try to be interactive so that the session will be more interesting and electrifying. Okay. So before jumping into big data Hadoop, let me start with data. So what is data? You can give the response by unmuting. Okay. What is your understanding on data? Any idea? What is data? Javed? Hello? Javed and others. What is data as per your understanding?
Data is which the user gives to us is called data actually for our.
Okay. In other words, that's good. That's good. Okay.
Data is the information in all user related data records and all collective information regarding any any type of materials demonstrate or present to the dashboard or any
Wonderful.
representation matter.
Wonderful. You're perfect. Correct. So data is, in simple words, someone said that it is collection of information, right? So you can say that data is nothing but unmute. Whenever you are going to say something, then only please unmute and you tell. Okay. Hello, please unmute. Please unmute. Others, please unmute. Hello, hello. Hello, please unmute others. There's a lot of background noise. Hello, there's some lady voice coming on. Please mute. Okay. So basically, data is nothing but a collection of facts and figures which are either processed or unprocessed. Guys, some background noise, please mute, guys. So you can call data as collection of facts and figures which are either processed or unprocessed. Now this data in computers has been classified into three varieties. One is structured data, semi-structured data, and unstructured data. So what is your idea on structured data? What is the structured data? Any idea?
For example, this is the pipe separated data, comma separated informations in the Excel. That is the structured data.
Have you heard of table data? Wonderful. Yeah. So have you heard about the word RDBMS? RDBMS. Any idea on RDBMS?
Yes, relational database management.
Relational database management systems, right? So what are the popular examples of RDBMS? What are the popular examples of RDBMS?
Oracle, Microsoft SQL Server.
Oracle, SQL,
Microsoft,
MySQL, Greenplum, all comes under
RDBMS.
RDBMS service where the data is stored in the form of rows and columns. Now, what is semi-structured data? Semi-structured data means the data that is partially structured. You can say your emails, PDFs, and then, weblogs. JSON. Have you heard about the word JSON data?
Yes, sir.
JSON
Yes.
stands for
Structured data, na?
semi-structured data.
Semi-structured data.
JavaScript object notation.
Hmm.
Now, what is unstructured data? Any idea? What is unstructured data?
Logs still comes under the unstructured data. Logs data.
You can say this raw data, right?
Raw data, right?
Audio files, video files, images, all comes under this raw data, means unstructured data. Perfect. Now, earlier also we have heard the word data, and now also we are hearing data, but why all of a sudden we are hearing a lot of buzz over big data for the past 10 years, right? So what exactly is big data and how much amount of data can be considered as big data? Let us discuss. Now, we are now living in a digital world, right? Data is the new form of oil. For every second, for every minute, we are generating lots of data. For example, have you ever imagined what happens online in 60 seconds? (2021) or 2021, we can see. Now here you see, I'm just taking the images, 2021 images. What is happening in the internet for 1 minute? So it will really surprise you. Now, Facebook, 1.4 million users, right? 1.4 million users are being logged into Facebook. Text messages, 21.1 million text messages are being sent. YouTube, 500 hours of content is being uploaded. From the Play Store, 414764 applications are being downloaded. And ShareChat, Instagram, Twitter, Thunder, and then if you see emails, 197.6 million emails are being sent for 1 minute. And if you see TikTok, and we are spending almost $1.6 million spent online. Netflix, 28,000 subscribers are watching. LinkedIn, connections of 9,132 users. Now all this is data, right? Most of the data is semi-structured. Now this is the magnitude of data that we are generating for 1 minute. Now let us imagine the magnitude of data that we are generating for 1 hour, 1 day, 1 year. It's very huge, right? It's in the order of terabytes, correct? Do you agree? So we are now living in a digital world. Data is the new form of oil. Within a single click, we are able to do everything, like booking the train tickets, plane tickets, bus tickets, movie tickets, and paying your electricity bills, mobile bills, LIC premiums, doing internet transactions, and doing online marketing, and you're doing your mutual funds transactions and everything within a single click. So all this is creating a lot of data. Okay, earlier generating 1 terabytes of data took months, but now generating 1 terabytes of data is within minutes or hours. Say, for example, from the evolution of mankind till today, if the data generated is 100%, more than 80% of the data has been generated in the last 1.5 decade. That is the power of the data that we are generating. So what exactly is big data is the first question. Now, I have a water bottle, 2 liters water bottle. I have a 2 liters water. And what is its capacity? It can handle up to 2000 ml, right? Now, when I'm trying to fill 2000.01 ml, what happens to this water bottle? What happens
Means it's overflow,
it will overflow. Why?
because that is it means that 0.1 ml is little more.
It is beyond its capacity, right?
Yes, yes, yes.
So this water bottle is designed to handle up to 2000 ml of water only. But when you're trying to ingest beyond its capacity, it is unable to store that and it is overflowing it. Likewise, RDBMS servers like MySQL, SQL, Oracle, Greenplum, DB2, Postgres, which are designed to handle certain storage like 2 terabytes, 4 terabytes, are unable to handle the volume of data that we are generating nowadays. And most of the cases, this data is either semi-structured or unstructured only. Okay. So in this case, we can call this 2000.01 ml as a big data to this water bottle, right? In simple words. Do you agree? All of you?
Yes.
So what exactly big data is? Any data which is beyond the storage, any data which is beyond the storage and processing capacity of a single centralized server and which satisfies three V's. Very, very important. Whenever you hear big data, remember these three words: volume, velocity, and variety. There is another fourth V people used to call veracity, but we normally refer these three V's: volume, velocity, and variety. Volume means the storage, velocity means the speed at which the data is being generated, and variety means all the three forms of data: structured, semi-structured, and unstructured data. So what exactly big data? Any data which is beyond the storage and processing capacity of a single centralized server and which satisfies three V's is known as big data. Okay. Till now, are we clear or any questions?
Clear, sir.
Clear, right?
Clear,
Sumit,
clear.
Shoaib, Satya Prakash, Narendra, Azim. If you have any, just raise your hands. Okay. Yes, sir. Okay. Limit crossed. Okay. Yeah, clear. Wonderful. Thank you. Thank you. Now, okay. We are now living in 2022. Now, tell me the ratio of people using smartphones nowadays. Out of 10, how many people are using smartphones?
9.9 around.
Yes, 9.9.
Out of 10, everyone is using smartphones. Let's go 10 years back, 2012. What's the ratio of people using the smartphones then?
It's a 2 or 3%.
2 or 3%. Those are the days where, if I go in another 10 years, there is no concept of smartphones, right?
Right.
We have a large walkie-talkies or Motorola phones used to communicate. So from 2004, with the advent of Facebook, there is a gradual change in the data generation. People started using internet like never before. Before Facebook, people used to go through the internet cafes. They used to stay for hours, 1 hour, 10 rupees, 20 rupees they used to pay. And then they sit for 1 hour, 2 hours, and they used to do all the stuff. But with Facebook, we have a lot of applications, and browsing capability has been increased, and people started browsing like never before. So this has increased the volume of data that we are generating, right? So Facebook is nearly generating 500 terabytes of data per single day. Amazon, Flipkart, eBay, flying airplane from one location to another location for a period of 1 hour is almost generating 10 terabytes of wind data, log data, temperature data, and everything. So all this is data is used, and there should be a space wherein you need to store this huge volumes of data, right? Now, we all know that Google is the fastest search engine. You give a query or you give a question to Google and it will retrieve the results in span of seconds with accuracy. So entire world is very curious to know how Google is storing the data and how it is processing the data. Okay. So Google has released a white papers about how it is storing the data and how it is processing the data. Google is using a technique called Google file system, wherein it is using to store large volumes of data, and it is using a technique called MapReduce to process the data. MapReduce to process the data. Parallel programming model. So what is this MapReduce parallel programming model? And what is this Google file system? Now, say for example, I will take 2 to 3 names, anyone, Ranga, Sandeep, or Mala, or anyone. Now I have 3 Gmail IDs. Okay. And every day I log in thrice to view the emails and everything. Okay. Now someone, how many Gmails you have? How many Gmails you use?
Per person 2.
2. And
Hmm.
say for example, you are logging thrice, watching.
Yes.
Others, Jitendra or Ranga, anyone?
No, I'm using 3 email IDs. I will log in more than 6 times.
Yeah. I'm just taking on average 3.
Okay, okay. 3, yeah.
Fine. And someone, some other name, Azim or anyone.
2, sir.
2. So for example, we are logging twice. Now here 4 users. Mine I'm taking 3 times, so I'm creating 9 weblog IDs. Okay, and then someone is using 2 Gmail IDs, and then they are creating 6 weblog IDs. Now some other is using 3 Gmails and 9. So total 9 plus 6, 15, 15 plus 9, 24, 24 plus 4, 28 weblog IDs we are creating. Weblog IDs means every time you log into Gmail, an IP address of ours will be logged into the Google server, browsing or caching all our activities. Say for example, I open Gmail and in the new tab I open Flipkart or Amazon, and I am browsing for a Peter England shirt, for example. And when it comes to the bag, checking out bag, I got a call. I went outside, and after 1 hour, when I open the new page, I will be receiving the recommendations, right? Regarding pop-up regarding the recommendations on the browser products, 5% discount, 10% discount, price slashed, and etc. for the same product I browsed. Have you ever observed that? You browse a product and in the next window you can see recommendations for the
Yes.
product that you are browsing, correct? Recommendations. So how do these people know that this particular user is interested in that particular product? Correct. So they have multiple algorithms running the predictive analysis, consumer behaviors, analytics algorithms by observing that a particular IP address is interested in this product. So why not we give more recommendations on this product? Because at the end of the day, their main motive is to make money from you, to do business from yourself, right? Now, I'm taking 50 crore people across the globe. I'm taking a small amount using Gmail twice a day. How many weblog records we are creating? 50 crore people using Gmail and they are logging twice a day. How many weblog IDs we are creating?
100 crores.
100 crore weblog records, right? 100 crore weblog records. So all these weblog records have to be stored under the Google server, right? So earlier the Google engineers have adopted a concept called vertical scaling. Vertical scaling means they used to store the whole data in a single centralized server. For example, let's assume that this server has a capacity of 5 terabytes. Now every day 100 crore weblog records are being generated. Okay, so 100 crore weblog records have been generated. So at one point of time, what these Google engineers have observed is this 5 terabyte server has been completely occupied. Okay. Now, what they have done is they have increased the resources on this same server to 3 terabytes. Okay. So, for example, 8 terabytes. But now the data is common, right? Every day, more than 100 crore weblog records they have to store. So at one point of time, they observed that this 8 terabyte server is also slowly piling up, and the system that it has designed to give maximum performance is now not working as per its specifications. For example, you have a laptop, right? You bought a new laptop, and initially during the first 6 months, it will be very fast. But once you start saving your files, softwares, and plugging your USB drives and everything, what happens to your system? What happens to your laptop? Say, for example, I'm ingesting, or I am plugging in my USB, which is having some 500 gigs or 1 terabytes of data. Does your machine respond fastly or slowly?
Slowly.
Very slowly, right? If you're trying to ingest another USB drive also, what happens? It will take some time to
Takes-
respond to your query, right?
Hmm.
The same thing is happening to that server as well. So what Google engineers thought is, okay, this approach of vertical scaling is not a good idea. Okay. Why? Because they are storing all the valuable data in a single centralized server. So if anything happens to that server, there is a possible loss of data or unavailability of data to the application teams, right? Because all your data is on a single server, correct? No other backup or anything is there. So what they've done is, instead of opting for vertical scaling, why can't we go for horizontal scaling? Horizontal scaling means they have taken a group of missions that are interconnected to a dedicated network, what we call it as a cluster. Okay, say for example, for our understanding, I have taken 5 servers which are connected to a cluster, and each server is of size, say for example, 200 gigs or 1 terabytes. Now I'm taking 1 terabytes of 5 servers. So the total cluster capacity is 5 terabytes. So whenever the data, new data is coming, what the Google engineers have done is they have simply added a new server to this existing cluster. Means any new data coming, a new server has been added. This has increased the scalability and also the performance levels of the cluster, right? So this has given birth to distributed. This has given a new birth to the distributed file system. Unlike storing the entire data in a single centralized server, okay, now we are storing the whole data into a group of machines that are connected to a cluster, right? So here this is known as horizontal scaling, and this has given to distributed file system. Now my files are stored across a group of machines distributedly. My data is spread across a group of machines, distributed across a group of machines. Okay. So this is known as distributed file system. This has given a many advantages. Okay. So Google file system, the first step is storing the data across a horizontal servers to increase scalability and fault tolerance of the cluster. Now, processing part. Simply storing the data doesn't give you any meaningful information, right? Until and unless you process. So Google engineers have adopted a concept called map reduce. So what exactly is map reduce? Suppose there is a park 5 kilometers, and there is one resource called A who is cleaning this park and it is taking him nearly 1 hour. Okay. Now, if I want to clean the park in less than 1 hour, what could be my possible options? What could be my possible
Increase
options?
the resources.
Perfect. Superb. Okay. So I have increased the 4 more resources. Now each resource is taking care of 1 kilometer. Okay, each resource is taking care of 1 kilometer. Now, if I ask all the 5 resources to start processing the work, in how much time it will take the park clean? In how much time I can get the park clean?
In the 15 to 20 minutes, I think.
Understand carefully. Earlier, there is only one resource A who is nearly 1 hour. Now, this I have hired 4 more resources, means total 5 resources, and each resource is now taking only 1 kilometer. They are now processing 1 kilometer only. Now, if I ask all the 5 resources to start processing, in how much time I can get the park cleaned?
12 minutes.
Wonderful. 12 minutes. Total time by number of resources, right?
Mm.
So 12 minutes. So my work has been come down from 60 minutes to 12 minutes. There is a drastic reduction in my time, right? Suppose if I've increased another 5 more resources, now total 10 resources are sharing, then how much time I can do? How much time my park gets cleaned? Instead of
6
5,
minutes.
6 minutes. Means more number of resources, less number of work, right? So this is called parallel programming model. The same logic now applies to this single node as well as this multiple nodes. Suppose there is a server 8 terabytes. All the data in this 8 terabytes. Let us assume that this is a park or 8 terabyte server. Now, if I write a program to process this data, my program has to scan entire 8 terabytes of data, and it has to process this data, which obviously takes some time. Now, the same program, when I ran across a group of missions, what happens? Now, my program is running not on 8 terabytes, on 1 terabyte, but the program is running parallelly on 8 missions, right? Obviously, processing 1 terabytes is easy or processing 8 terabytes is easy. Which will take more time, processing 1 terabytes or processing 8 terabytes?
1 terabyte is
8 terabytes takes more time. So here we have a 1 terabytes, it will process very fastly, right? Now my program is processing 8 such missions. So all my 8 terabytes will be processed very fastly, right? This output is again consolidated and then sent back to the client after processing this. So this is known as map reduce mode. Map reduce mode. Are we clear on this? What is Google file system and what is map reduce? Everybody, or any questions? We are not. Yeah.
Could you please repeat the map reduce concept one more time,
Okay,
if
fine.
possible?
So I'm telling you that map reduce is a parallel programming model. If a work has to be done by one individual, it will take some time. The same work, if it is shared by multiple users, I can get the work done in very less time, right?
Yeah.
Common principle. Likewise, there is a 8 terabyte server, and then there is a data, say for example, 5 terabytes of data. Now, if I want to analyze this 5 terabytes of data using a program, my program has to run on this machine and it has to process the 5 terabytes of data, right?
Yes.
Which obviously takes some time.
Yeah.
Now, say for example, if I submit the same program to this cluster. Now my 5 terabytes of data is sitting across 5 different machines. Correct? 1 terabytes,
Yes.
1 terabytes, 1 terabytes, 1 terabyte. Now
Yeah.
my program is processing the same 5 terabytes, but it is processing on 5 different machines concurrently, parallelly, right?
Yeah.
So here, if you observe, each machine is processing 1 terabytes. Obviously, which takes very less time, right? Compared to 5 terabytes on a single machine.
Yes. Yes.
So here, if it is taking 30 minutes, it may take 5 to 10 minutes here. But
Yeah.
all the 5 servers are processing concurrently. So all my 5 terabytes can be processed in very less time, right? So this is
Yes.
called MapReduce programming model, processing large volumes of data that are stored across a group of machines, okay, for analysis or for analyzing the data. This has given a concept to MapReduce. Now Google is using this
Okay.
technique MapReduce to process the data efficiently from 2004. Okay. Now what is the connection of
Okay.
Hadoop and everything we'll discuss. Google, with the advent of internet, they just want to analyze the index of the internet pages that are being browsed by the users. What now we call as TRP ratings for serials, movies and everything, right? So they just want to analyze which page is being browsed by most of the internet users. So that they have created one project. I'm not sure that name, for time being, just make sure that it is a Netiza project. In this project, there is one guy called Duck Cutting who is the member of this project. As it is a Google project, it is using Google file system to store the data and MapReduce to process the data. Okay. Duck Cutting is very much interested in this Google file system and MapReduce, and he has done some modifications to Google file system, and he has taken MapReduce as it is, and he has created a new project called, okay, by modifying Google file system and MapReduce. Okay, so after creating the project, he has to rename the project, right? So he thought of thinking several names, and finally he saw his kid playing with a elephant toy, and that elephant toy name is called Hadoop. So Duck Cutting has renamed this project as Hadoop project. The GFS file system, Google file system, that he has renamed is known as HDFS, Hadoop distributed file system, and he has taken MapReduce as it is, and then he created a project called Hadoop project. Later Apache Foundation has taken this project. Apache Foundation is a non-profitable organization, so it has overtaken this Hadoop project and it renamed as Apache Hadoop, which is now a very big project from Apache Foundation. So what exactly is Hadoop? Hadoop is a open source software framework completely written in Java to handle big data. So what is open source software? Any idea? What is open source software? Any idea? Guys, what is open source software?
Anyone can use without paying.
License free, right?
Can use the
License
software.
free.
Yeah. Yeah.
You can easily download it from the internet, correct? So Hadoop is an open source
Yes.
software framework completely written in Java to handle this big data. And again, what is big data? We just now discussed big data as 3 V's: volume, velocity, and variety. Correct? Volume, velocity, and variety. So to store large volumes of data and to process that data, big data Hadoop is used. Now let us see what are the ecosystems of Hadoop and how Hadoop is used to store the data. We will be discussing. Okay. Now, what are the 3 different data generators we are having in real-time world? Structured data, semi-structured data and unstructured data, right? So this is structured data, semi-structured data, and unstructured data. Now, suppose you have used HDFS to store its data, because the storage part is known as HDFS, right? Hadoop Distributed File System, HDFS. And what is the processing part?
MapReduce.
MapReduce. So whenever you are hearing Hadoop, remember two parts, storage part and processing part. Storage part is known as HDFS and processing part is known as MapReduce. Now, you have three different data generators. How do you import the data from RDBMS is the first question. I have a data in MySQL or Oracle mainframes. How do you import this? For this, Apache Foundation has given a new tool called Scoop, which is known as SQL plus Hadoop. So using Scoop utility, we can import the RDBMS data into your HDFS. Now, what about semi-structured data and unstructured data? Semi-structured data and unstructured data. You can ingest this semi-structured or unstructured data using Apache Flume or Apache Storm. Okay. So once the data is stored in HDFS, simply storing the data doesn't give you any meaningful information, right? Until and unless you process. So it has to be processed. So you write a MapReduce program. As Hadoop is completely written in Java, you write MapReduce programs using Java only. Here comes the problem most of the participants ask. I'm not good at Java. I'm not a Java developer. So what are the possible ways of learning big data? Can I have an option to learn big data? Yes. For non-Java programmers, Apache Foundation has given two important skills called Hadoop ecosystems, Hive and Pig. Okay, Hive and Pig. Apache Foundation has given two important ecosystems called Hive and Pig. Hive is like a data warehouse which uses a language called HQL. HQL means Hive Query Language, which is almost dialect to SQL query language. So if you know SQL query language, DML, DDL commands and other advanced commands, learning Hive is very, very easy. There comes a new ecosystem called Pig. Pig is like a scripting language, data transformation language. Okay. Now, whatever query you give, either it is a Hive or Pig, internally it gets converted into MapReduce only. Okay. That is, instead of writing 100 to 200 lines of Java code using MapReduce, you can achieve the same result using Hive and Pig with 10 to 15 lines of queries. Such is the power of these two ecosystems. And then there we have another ecosystems called Zookeeper, which acts like a distributed coordinating service, Spark, in-memory processing engine, Kafka, universal messaging distributed system, and Uzi, work scheduler. Okay. With this growing data, which is almost semi-structured and unstructured, there are new generation databases called NoSQL databases. NoSQL databases like HBase, Mongo. So all these components constitute a Hadoop cluster. So what is this course? What is the use of learning this course and what are the advantages of this course? So we will be training the participants in such a way that in the market we have Hadoop architect, Hadoop admin, and Hadoop developer. Architect is a person who has a complete control of enterprise application integration. So we train the participants in such a way that this course is like more of a mini architect, 25% of administration and 75% of development. Okay, so the after completion of this course, you can see yourself minimum 2 to 3 years experience in big data Hadoop technologies. Such is the what is the knowledge that we will be sharing you for this rest of the 40 hours. We'll be touching the HDFS, MapReduce, and all the ecosystems. And also, I'll be making sure that you understand cloud technologies as well, Microsoft Azure, and then Databricks and AWS as well, which is really hot in the market. So I'll be explaining the all topics regarding the storage part, processing part, Spark, Mongo, HBase, and running the Azure Databricks and building the clusters on AWS. Everything will be taught in more clear manner. After every class, I'll be giving you some questions. You need to prepare answers which covers your technical as well as your interview skills. This is how we are training the participants for the last 4 to 5 years, handling hundreds of participants who are now happily working in India onshore as well by following my instructions. Right now, big data Hadoop, big data engineering is boom in the market. Companies are shelling huge bucks for the participants who are having these skills. So if you dedicate your career for the next 2 to 3 months on this big data Hadoop, I can bet that if you sincerely work, you can really get amazing opportunities in big data. Yes. 40 hours means it's not like exactly 40 hours I'll be taking. It may extend to 40 hours or 50 hours. Okay. Doesn't mean that exactly after 40 hours the course is completed. Yes. Spark introduction, RDDs, actions, transformations, PySpark, Scala. The prerequisites basically you need to have a system, laptop 4 GB, minimum 4 GB to 6 GB, and then MySQL, some knowledge, Linux commands. If you do not have anything also, it's fine. I will start explaining you all these concepts. Okay. As we are running out of time, coding background required. See, basically we are going for development, right? So I request, if you have not yet known any language, try to start exploring Python. It will help you a lot. The fee and everything you can check with the management team. So this is the first demo. Sir, I have this covers administration, Amazon EC2. What about labs? Wait. Can I get big data engineering job? Everything I will answer. Don't worry. This is the first demo. Tomorrow also we have a demo at the same time. I will explain more about this big data Hadoop ecosystems tomorrow. Come up with a clean mind. Okay. And then I will give you everything what you need and I will answer your queries happily. This course is not for Hadoop admin and I told you, right? It's a mixture of administration and development, mini architect. Okay. Jitendra, you will be knowing the installations as well as you will be knowing the analysis as well. So any questions? If you're okay, we can start the second demo. And once you understand, I can better answer your queries in tomorrow's session as well. Try to attend tomorrow's session as well to get some in-depth understanding of big data Hadoop. Then we can, explore the opportunities and I can answer your questions more easily. Is that fine? Sumit, Shoaib, Sejal, Nilesh, Pradipta, Sandeep,
Yes.
Nilesh. Yeah.
Yes.
Okay.
So, sir, just one question. This course timing is 8 to 9
8 a.m.
every
to
day?
IST. Yeah.
Okay.
Okay. And weekdays, weekends, according to your availability, I can plan on Saturday as well.
Okay.
Thank you so much. Much appreciated. Yeah, CDP distribution, installation, etc. Correct. So please join tomorrow as well. I'll be extending these topics for tomorrow's, like how to install Ubuntu, Hadoop on Ubuntu, what is EC2, everything I will introduce you. Okay. Much appreciated for your time And thank you so much for your cooperation and patience. Thank you so much, guys. See you tomorrow, same time, 8 a.m. Thank you so much. Thank you so much. Yeah. Have a nice day.